Hello. Today we are going to learn how to compute several key statistics using real world examples. And the way I like to introduce this is by telling you what we're going to do in plain English, because if I start getting into the statistics right away, it becomes confusing. So what we're going to try to find out is how two sets of data are related. In this example, we're going to look at stock prices, but this technique that we'll use to find out how two sets of data are related can be applied to almost any situation. In class, we were talking about how some people say there is a relationship between the phase of the moon and the number of people who give birth, so that somehow live birth is related to the phase of the moon. So one way we could test that is by checking the total luminosity of the moon, which would indicate its phase, where the highest luminosity would be when the moon was full, and the lowest luminosity would be when there was a new moon or no moon visible. And we could compare that data to the number of live births. So and we can use the equations that we're going to learn today in order to actually find out if that claim is true or false. We can't claim that the moon causes live births, but we could find out whether there is any relationship between the phase of the moon and live births. So it's something to think about, but that's just one of the things that you can do with that data. It's a very highly various and applicable tool. It's very what's the word I'm looking for? There's great dexterity to this tool, but saying how to find out how two sets of data are related, this phrase right here, this is a good English sentence, but the mathematics of it is still important. So today we're actually going to learn out how to calculate the standard deviation and the correlation coefficient. Now, these are basic statistics calculations. They are not difficult, and I'm going to break them down for you into several easy steps. You just have to kind of follow along. So please pause the video as needed. Rewatch the parts you don't understand. The only material that I'll use during this is maybe a pen and a pencil and a four-function calculator that has a square root function on it. Really just a basic calculator. You don't need a lot of fancy equipment to do this. If I remember at the end of this, I'll show you how to very quickly compute this information in Microsoft Excel, but jumping to that conclusion would not help you at all. So we're going to go through it step by step. So I'll let you get your things ready while I get my materials ready as well. Okay, let me clear the deck here and show you this form. Now, this actually has the correlation coefficient formula printed on it right here, and it looks terrifying. I actually want us to take a look at this for just a minute, and rather than explain this to you before you understand how to compute it, we're going to compute it, then come back to the formula, and it will make more sense. But I'll just describe what you're looking at. Now, as I'm talking, I'm going to refer to the correlation coefficient by its Greek letter. And this looks like a P, like an English P, but it's actually the Greek letter rho. Rho, R-H-O, rho. And that's the Greek letter that looks like that. Okay, so that's rho, and that is equal to the correlation coefficient. So this is the correlation coefficient. And I think it's important to describe what it is that we're going to find with this insane equation. I was telling my students it looked like if you plug this equation into a supercomputer, it would blow up the universe. I mean, it just looks scary, but it's not. It's not. It's really cool actually. And when you figure out how to do it, you can go show your friends, show your parents, call up the newspaper, let people know that you're a genius. Because if you show basically anyone this formula that isn't familiar with statistics, they're going to think you're a genius or a lunatic or both, which isn't necessarily a bad thing. Okay, so this correlation coefficient is a number. So, ladies and gentlemen, it's a number. It's not scary. It is a number between -1 and 1. All right, so inclusive. It is a number between -1 and 1. Okay, so and that would be less than or equal to. So it's inclusive. And we're going to talk about 3 special cases of the correlation coefficient before we begin the actual computation, just so you get an idea of how this is going to work. I guess I will need a third supply. You don't need this, but I'm going to use a ruler here. Let's take 3 different correlation coefficients. I'll just draw these 3 little graphs and it will explain everything. Okay, so this will be the graph for a correlation coefficient of -1. This will be the graph for a correlation coefficient of 0. And this will be the graph for a correlation coefficient of 1. So here, rho equals -1, rho equals 0, and rho equals 1. Right? So what a -1 correlation coefficient indicates is that the 2 sets of data are related, but they're inversely related. That is, if the first column of data, if one of those numbers goes up by 1, then a correlation coefficient of -1 will tell me that the other data will go down by 1. So we'll take a look at that. The way that looks on a graph is a downward sloping line with a slope of 1. So this is a downward sloping line. If I'm going to skip the 0 for just a moment, but we'll talk about, give you an example of some data that are negatively correlated. In economics, demand has a negative correlation. The quantity demanded, if this is demand, and this is quantity, and this is price, the quantity demanded varies inversely with the price. So if the slope is right on that demand curve, if you have a correlation coefficient of -1, if the price goes up by $1, the demand will decrease by the same percentage, because the slope here, the slope, the rise over the run, is -1, -1 slope. Now over here on positive, well, if that was negative, then this is positive. A upward sloping line, again, with a slope of 1. All right? Some examples would be, and this is where I like to be a little bit funny. In economics, we could talk about supply having a positive correlation, but I want to use something that people can relate to. Oreos and milk are made for each other. They go together. So more Oreos, more milk, right? We want a 1-to-1 relationship there, Oreos and milk. Good correlation coefficient between Oreos and milk. Now, let's look at this special case right here. This one's harder to show visually because there is no relationship here. So we've got a perfectly positive relationship with a correlation coefficient of rho equals 1. We've got a perfectly negative correlation relationship with rho equals -1. But when rho equals 0, it's no relationship whatsoever. None. Now, Again, more preamble. The way this will look, if I'm drawing it, see if I've got a different color. Yeah. See if this will show up. If I'm actually depicting my data, you won't see lines like this. You'll see data. And the data will be scattered around this imaginary line, but the data will kind of look like this. It will have a trajectory that is down, and it will be scattered in such a way that when you look at it, the correlation is that it's inverse. And here is the opposite. When there's a positive correlation coefficient of 1, the data is clustered around this imaginary line, and it's upward sloping. Okay, but it's not a line, it's data points, X and Y values. Okay, now when the correlation coefficient is 0, that means that there's no relationship. Like we might have a data point here, and then I might have another point here, I might have a point here and a point down here, point over here. It's just we can't do anything with the data. There's no correlation between the data. Okay, well, most cases are neither the perfectly inverse, perfectly correlated, or zero correlation. They're none of these. They are instead some degree of correlation. We'll take a look at that, but that's enough for now. If I talk for any longer, you'll lose the thread. So in order to make life interesting, we will look at an actual example. So we're going to keep this economics related. So we're going to compare the correlations, coefficients of Twitter, Caterpillar, and Apple Computer. All right. So before I flip the page over, well, I guess I'll flip the page over. Why not? Here's the stock data. This is historical stock data for Twitter, Caterpillar, and Apple. These are their stock symbols, TWTR for Twitter, CAT for Caterpillar, and AAPL for Apple. These are the historical stock prices starting on March 22nd of this year and going up to April 5th. So I have 10 days of stock market data. And then these are the prices at the closing bell for each of these stocks rounded to the nearest whole number. Okay, so this is real data that I took off of the NASDAQ or Yahoo Finance historical prices website. Well, let's do some hypothesizing. If we're thinking about whether these are related to one another, just before we start, which companies do you think are related to one another? Well, Caterpillar is a heavy equipment manufacturer, Twitter is a social networking company, and Apple is a technology company that makes iPhones and MacBooks and other devices. They also make a lot of software. Okay, so here's the key. These two have something in common, don't they? They're both technology companies, and Caterpillar is a heavy equipment company. So when you're thinking about stocks, you would think if there is a correlation, a positive correlation here among these three stocks, we'll call this the portfolio, then it would be between Twitter and Apple. Since they're both tech companies, we would think that even though their stock prices are different, even though their stock prices are very different, Twitter's trading in the $30 range and Apple is trading in the $170 range, we would say that they would still probably go up or go down together. They would move together. They would be correlated. That's the correlation. They are correlated. Well, we'll see if that's true. We'll also take a look at Caterpillar and Twitter to see if there's any correlation between Caterpillar and Twitter. There may not be, all right? But we'll try to find out. And here's how we're going to do it. This table is not meant to frighten you. It's meant to make life easy for you. And actually, it's just a matter of filling in the values on this table to arrive at the correlation coefficient. And we don't have to try to remember this scary equation. So let's just start. Well, in column 1, I'm literally asked to transcribe the values for Twitter, because we're calling Twitter X and Caterpillar Y. I'm literally asked to go up here and transcribe these values down into my table. So I'll just do that really quickly. 29, 28, 28, 28, 29, 28, 28, 32, 31, and 31. Okay, and I'll do the same for Caterpillar. Go up here, 148, 145, 145, 144, 147, 145, 147, 149, 144, and 147. Okay? So that's all I did is I just wrote the values down. Now there's only 11 columns on this graph, on this table, so you're a good ways done. 18% or so done. So now the next thing we're asked to find is the X mean. All right. Now let's go back here. That's there. X mean is right here. This is the X mean. Sometimes you see this written as X bar, X with a bar over it, right? This is the Y mean right here. Sometimes you see that written as Y bar, right? By the way, this Greek letter right here is this one right here, and it kind of looks like this. That's called mu. Mu. So we can call it mu x, x bar, mu y, y bar. It's the same thing. It's the mean of whatever I'm talking about. Okay, so x mean or x bar or mu x. So I'll call this x bar or I'll call it mu x. How do I compute that? Well, we're going to be computing, this is important. So as you continue, remember what we're computing today is the population. We're going to compute the population and not the sample. Now that's key, and it becomes relevant later on. Okay, so we're going to compute the mean. Well, for the purposes of this illustration, we just need to compute the simple average of these values for x and put it here. And then compute the simple average of the values for y and put them here. It's pretty simple. So what is the average for x? All right, that's just 29 plus 28 plus 28 plus 28 plus 29 plus 28 plus 28 plus 32 plus 31 plus 31. Okay, so there's my little, I've got this sum. This is sigma, that big weird looking E. Okay, that's 292. Well, what do I divide 292 by? Well, how many values are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 values. Incidentally, that means that n, which comes into play later, equals 10. Okay? So there's 10 values. So I just take 292 and I divide by 10. And that gives me 29.2. That's my mean or my average for x. So I'm going to put 29.2, and then you need to write this in every single box, 29.2, 29.2, and so on, 29.2, 29.2. Why am I forcing you to write it over and over again? Not to torture you, promise. It's just that as you go through this, it will make it easier for you to refer back and forth. If you've written out this value, your eyes can track just on the row. You don't have to be jumping up and down. All right, now let's compute the Y mean. Okay, so this is y bar or mu y. Let's compute it. Here are our values. That's 148 plus 145 plus 145 plus 144 plus 147 plus 145 plus 147 plus 149 plus 144 plus 147. And that comes up to 1,461 for the sum there. And I'm going to divide that by 10. And I get 146.1. So here I'm going to put 146.1, 146.1 over and over again, all the way down. One 146.1, 146.1, and lastly 146, drumroll, 0.1. All right, now we're ready to do some actual statistics. X minus X mean. Oh boy, what does this mean? Well, what it means is for you to take 29 and subtract out 29.2. So 29 minus 29.2, it means that X minus X mean is negative 0.2. Okay, that's literally what it means. Negative 0.2. Okay, but it's important that you understand what's going on visually. So here's what's really going on. We have this data, all right? And we have our X bar or our mu X right here. And that's equal to 29.2. Well, all of our values for Twitter vary around it. And they vary around it. Let's say the first value comes in at 29. So this is 29.2. I'm going to indicate this. We'll put over here 29.2. Okay, that's the mean. And so that's the mean. My actual value, my first value is 29. So if I go over here, my first value is actually lower than the mean. It's 29. So what I'm looking for is this distance between the value and the mean. And that value is minus 0.2. Okay, so let's take a look at the next value. X minus X mean. The next value is 28. Well, my mean is 29.2. So again, below the mean. Let's go over here. My next value is 28. We'll put that here. What is the distance that it travels up to the mean? Well, it goes down from the mean. Take 29.2 and you subtract out 28. You're left with 1.2. Well, it's negative number because the mean is 29.2. So I suppose what I should have done to not confuse anyone is to take the price that's given and subtract out 29.2, and I get minus 0.12. You see that? So this again, this value is minus 1.2. So that's actually what I'm going to put down here. Minus 0.12. Minus, I keep messing up, minus 1.2. All right. So luckily for you and me, this is the same number twice. So I've got minus 1.2. All right, minus 1.2. And then I already did 29. That's minus 0.2. 28 again, minus 1.2. 28 again, minus 1.2. 32. Aha, something new. All right, so by the way, the whole time, I'm going through, I'm modeling this however it is. So 28, 28, 3 of these, 28, and then here's one at 29, and then 28, 28. Well, now I've got a new situation where I've got a price up here, way up here at 32. Okay, guy's up there at 32. Well, what is his distance to 29.2? What is that distance there? That's the x minus x mean. So, this is x, and this is the x hat. This is the mean. So what is this distance? That's x minus x mean. Well, it's just the price that's given, 32, minus 29.2. That's the average, or the mean. That's 2.8. So for this value, it's positive 2.8. We'll go down here and we'll put 2.8. Then I've got 31. All right, so my next value is 31. Okay, so what is that vertical distance there to the mean? Well, you can calculate it easily. 31 minus 29.2. And it says 1.8, positive 1.8. So I'll go back to my chart and I'll put in 1.8, 1.8, and then it says 31 again. So just to finish off, I've got 31 again. Let's fill these in. So this is all of this data modeled in a chart. So I need to put here, I need to put another 1.8. Okay, does it ask me to add it up at the bottom? No, no. It just tells me to go on and do the same thing for Y. Well, Y was the price in Caterpillar minus the average price for Caterpillar. And I'll run through this rather quickly. What we're looking at here, Y minus Y mean, I'm not going to draw it all again. The Y value is here in column 2, and the Y mean value is in column 4. So whatever column 2 is, I'm going to subtract from it 146.1. So that's 148 minus 146.1 equals 1.9. 145 minus 146.1 equals minus 1.1. There it is again, minus 1.1. 144 minus 146.1 equals minus 2.1. 147 minus 146.1 equals 0.9. 145 minus, I already did that one. See, I can kind of put minus 1.1. 147, I had that before, that's 0.9. 149, haven't had that one yet, so we'll compute it. 149 minus 146.1, that's 2.9. Okay. 144, I had him up here, that's minus 2.1. And then 147 was 0.9. Okay, good. Now we move on to columns 7 and 8. See how we kind of take these together? These kind of go together, these kind of go together, these kind of go together. Well, these kind of go together too. We're just asked to do one thing on column 7, I'm asked to do something to column 5. It says here x minus x mean. Well, that's what that said, x minus x mean squared. Okay, so all I'm going to do is take whatever I've got here and square it. Now, everybody knows when you square a negative number, it becomes positive. So as I'm typing it into my calculator, I'm not going to waste time typing the negative number. I'm just going to say, if you have a square function on your calculator, good for you. But I don't, so I'm going to say 0.2 times 0.2 equals 0.04. Right, so that's my value there, 0.04. And here, the next value is 1.2 times 1.2 equals 1.44. Again, 1.44. And again, 1.44. Okay, so minus 0.2, we already had that. That's squared, that's 0.04. Again, 1.44. And again, 1.44. Okay, 2.8. All right, let's square 2.8. 2.8 times 2.8 equals 7.84. 7.84. Okay, 1.8. Right, let's square that. 1.8. 1.8 times 1.8 equals 3.24. So that goes there, 3.24. And I got the same thing again. So that's just 3.24. And this one does want us to add it up. Okay. So we'll take 0.04 plus 1.44 plus 1.44 plus 1.44 plus 0.04 plus 1.44 plus 1.44 plus 7.84 plus 3.24 plus 3.24. And that equals 21.6. Okay, 21.6. Well, good enough. So now we're just going to do the same thing for the y values. So this says y minus YMean squared. So we take, in column 6, I'm just going to square all the numbers in column 6. So again, I'm going to run through this relatively quickly. And I'm not going to put the negative signs because when I square a negative number, it becomes positive. So the first one is I take 1.9 times 1.9, and that equals 3.61, right? And then I take 1.1 times 1.1, and that equals, 1.1 times 1.1 equals 1.21. Again, 1.21. Looking here, negative 2.1, so I'll say 2.1 times 2.1 equals 4.41. 0.9. Okay, 0.9 times 0.9 equals 0.81. 1.1 again, I did that already, 1.21. 0.9, I did that, that's 0.81. 2.9, haven't done that yet. So 2.9 times 2.9 equals 8.41. 8.41. And minus 2.1, I already did that, that's 4.41. Okay, so I'll put 4.41 there. And then 0.9 again, I already did you. It's 0.81. Okay, so now I'll just add up this whole column, right? 3.61 plus 1.21 plus 1.21 plus 4.41 plus 0.81 plus 1.21 plus 0.81 plus 8.41 plus 4.41 plus 0.81 equals 26.9. 26.9. Okay? The next thing asks us to compute x minus x mean over STDVeX. What is that? Well, STDVeX is the standard deviation of x. Well, we got to find out what that is first, and that's kind of an intermediate calculation. So let me model that for you. The standard deviation, or sigma for x, this is the standard deviation, STDVeX, standard deviation. And that has a formula, okay? And that formula is the square root of the sum of the squared differences from the mean divided by the population size. In this case, we're calling that n, okay? Calling that n. Okay, so in order to compute this, we have to pull some values from our table, which we actually have. It says here we need the sum of x minus x bar squared, right? Well, we know that x bar means the mean of x, or x mean. So do I have anywhere where I've calculated the sum of the squares of the differences between the x values and the average x, or mean x? Let's go over here to column 7. And if I look down to the bottom of column 7, I find that I have indeed calculated the sum of the squared differences between the mean. Okay? So now I have the numerator under the radical. Okay? So let's go over here and say, well, we've already got some of this information. It's not looking so difficult anymore. This guy right here, this whole scary looking thing, is 21.6. Okay? So this is just 21.6. And we said earlier that n was 10 because there are 10 stock prices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. I just put a 10 in there. So what I need to do to solve the standard deviation for x is to divide 21.6 by 10, which is 2.16, and then take the square root of it, right? That's what I'll do. I'll take 21.6 divided by 10. That's equal to 2.16. And then I'll just hit this square root button right here to get the square root. 1.469, we'll round to the second decimal and say 3 significant digits, we'll say 1.47. So this is equal to 1.47. That's the standard deviation of x. All right, so if I want to make a little note down here, I can say sigma x equals 1.47. And that'll be a reminder as I move forward. Now I need to calculate the standard deviation of y. All right, so I'll write it out. Should have put an X there. The standard deviation of y is sigma y equals, and I guess I'll write it out, standard deviation for y, and that's equal to a big radical sign, and that is the sum of the squared differences from the mean of the y values this time. So y minus y bar squared, the sum of those divided by n. All right, well, thankfully we know some of this information already. So we're going to put that radical sign back, but we can import some data. Do I have anywhere where I have calculated the sum of the squared differences from the mean for the y values? Well, let's take a look down here at column 8. Right there, 26.9 is the sum of the squared differences from the mean for the y values. So I just go up here and put 26.9, and we know that n equals 10, so that's there, right there. And if I divide 26.9 by 10, I get 2.69. Take the square root of that, and I've got the standard deviation for y, or caterpillar. So let's take 26.9 divided by 10, get 2.69, and then I hit the square root sign. I got 1.64012, round to 3 significant digits, 1.64. This is equal to 1.64. Okay, so that is sigma y. If I want to go back to column 10 and plug that value in, STDVY, I'll plug in sigma y, or standard deviation of y, is equal to 1.64. Okay? So now we'll just proceed, because this stuff is actually pretty simple. It says here x minus x mean divided by 1.47, or the standard deviation of x. Well, have I gone anywhere on my table where I've done x minus x mean? Yeah, I do, actually. It's over here in column 5. You know? So like one way of saying in column 9, it's saying take the values in column 5, okay, and just divide by the standard deviation of x, or 1.47. Okay, so like as an example, what I'm going to do here is take x minus x mean, that's minus 0.2, remember the minus sign, and I'm going to divide by 1.47 for the standard deviation. Okay, so what I'll do is, just as an example, I'm going to make a minus 0.2 divided by 1.47, and that gives me minus 0.136, 3 significant digits, minus 0.14. All right, depending on how you round, this is where your differences will show up from mine. If you're rounding to different significant digits, your answer will be a little bit different, but the interpretation won't change. Okay, so let's continue. This one I need to do minus 1.2 divided by 1.47. I'm getting these values from right here, and that's minus 0.816, or we'll round again to minus 0.82. And again, it's the same number, so again, minus 0.82. Again, minus 0.82. Okay, so minus 0.2, I already did that. That's minus 0.14, minus 0.14. Okay, back to minus 0.12, so I'm going to, this is minus 0.82 and minus 0.82. 2.8, this one I've got to calculate, so I got positive 2.8 divided by 1.47, or the standard deviation of x. I got 1.904, I'll call it 1.90, so that's positive 1.90. 1.8, so I take 1.8 divided by the standard deviation of x of 1.47, and I get 1.22. Okay, 1.2. And then I've got that same thing again, so 1.2. Very good. Now let's keep firing on all cylinders. Our standard deviation of y is 1.64. Column 10 is asking me to go over here to column 6. Take column 6 divided by the standard deviation of y, which is 1.64. Okay, So this is actually really simple. We're looking at y minus y mean divided by the standard deviation of y. So I'm going to take, for the first row, 1.9 divided by the standard deviation of y of 1.64. And I'm going to get 1.158, or we'll call 1.16, round to significant digits, 1.16. And this is minus 1.1. I'll do minus 1.1 divided by 1.64. And I'll get minus 0.67. Minus 0.67. All right, my next value, same thing, minus 0.67. We'll do minus 2.1 for the next one, divided by 1.64 equals minus 1.28. So that's minus 1.28. And the next value is 0.9. I'll take 0.9 divided by 1.64, and I get 0.548 or 0.55. 0.55. Next value is minus 1.1. I already did that one. Minus 0.67. 0.9 again. That's 0.55. 2.9. Haven't done that one. So 2.9, we'll say 2.9 divided by 1.64 is 1.768 or 1.77. 1.77. Minus 2.1 again. I had that before. That's minus 1.28, minus 1.28. And then 0.9, I had that guy before, 0.55. 55. Not bad. Now in column 11, I'm just asked to multiply columns 9 and 10. All right. So I don't even, it's pretty simple. I'm just going to take minus 0.14 times 1.16. Just move down the list. So that's, I'm going to add the decimal. Keep your eye on those decimals. It's important. So in this one, I've only got one value with a decimal, so my value is going to be negative. So however you want to keep track of those minus signs, but keep track of them. So I'm going to say 0.14 times 1.16 equals minus 0.16. Minus 0.16. In my next row, I have two negatives, so it's going to be a positive number. 0.82 times 0.67 equals 0.549 or 0.55. Positive 0.55. And again, same thing. 0.55. Now I do two minuses again, so I'm going to do 0.82 times 1.28. That gives me 1.049 or 1.05. 1.05. Next is 0.14 times 0.55. This is going to be a negative number of 0.077 or 0.08. So that's negative 0.08. Careful with the negative because there was only one negative there, right? And my next value, I already did this one. This is two negatives. I had this guy up here twice. So that's again 0.55. Okay, so I've got now minus 0.82 times 0.55, so it'll be a negative number. Take 0.82 times 0.55, so it'll be negative 0.45. Negative 0.45. Just be careful with the negatives. That's what will really screw you up. Here are two positive numbers, 1.9 times 1.77, and that's 3.363 or just 3.36. 3.6. Getting close. 1.22 times negative 1.28, so that'll be a negative number. 1.22 times 1.28 equals negative negative 1.56. So that's negative 1.56. And finally, 1.22 times 0.55, two positive numbers. 1.22 times 0.55, that equals 0.671 or 0.67. Okay, fair enough. Now we just add these up. It says to make a sum down here. It's important. Let's add them up. I'm going to say minus 0.16 plus 0.55. Be careful. Plus 0.55 plus 1.05. Okay. Plus minus or whatever, how you want to do it. Plus, and then do minus 0.08 plus 0.55. Then you can do plus minus 0.45 plus 3.36 plus minus 1.56 plus 0.67 equals 4.48. Okay, so the sum down here is 4.48. Okay, well, what have I got? Can I now compute the correlation coefficient for Caterpillar and Twitter? Let's see. Let's take a look at my graph. I know n is 10, so I've got that. I calculated, did I calculate these values? Yes. This is x minus x bar and y minus y bar. I got that calculated. We divided it by the standard deviations for the respective columns. See what I've done here? X minus x mean divided by standard deviation of x. Okay. Y minus y mean divided by the, so you can't even see what I'm doing. Let me fold this. Here, look at the formula. See what you did already. X minus x mean divided by the standard deviation of x, and then y minus y mean divided by the standard deviation of y, and then in column 11 we multiplied them together. Okay, and then we, at the bottom of column 11, I added them all up. So what this formula is saying is that I've already done all of this. So that's done. All I need to do is multiply 4.48 times 1 and divide it by n minus 1. Well, n is 10, so 10 minus 1 is 9. So I'm going to take 4.48 times 1 divided by 9. Right, so down right here, we'll put rho is equal to 1 over n minus 1 is 9. Look back at the formula if this is confusing. Times this value right here. This guy right here, 4.48. So I'm going to say times 4.48. So I'll take 4.48 and divide it by 9. And I get 0.4977. This equals 0.4977. Well, if we go to 3 significant digits, you'll get 0.50. All right. So let's ask ourselves the question, are Twitter and Caterpillar, this is the correlation coefficient, okay, it's 0.5. remember, a correlation coefficient of 1 would have had this perfectly upward sloping graph. -1 would have been a downward sloping graph. So we're kind of halfway here with 0.5 between 0 and 1. So if I'm plotting the data, I've kind of got, I don't have a one-to-one relationship, but I kind of have a weaker, if this is, let's take a look at the graph. I want you to see this visually. Like a perfect correlation would be a 45-degree angle right there. That would be a perfect correlation with the data. But we don't have a perfect correlation. We have a 0.5 correlation. So that gives us a, split the difference here. This is our value right there with rho equals 0.5. Okay, so it's kind of a positive correlation, but weak. It's weak. It's not really positive. It's not a perfect positive correlation. What that means is that the data are kind of bound to each other, but very sort of loosely. They're loosely bound. So that's a middling sort of correlation coefficient. But, ladies and gentlemen, that is what you got, 0.50. I'll use a fresh equation. You found all of this. You found the standard deviations. You found the means, the differences from the means. You were able to compute the sums of those things. You filled out an enormous table of data. And you found and interpreted the rho value, or the correlation coefficient, for Twitter versus Caterpillar. So if somebody says are Twitter and Caterpillar correlated, you say, well, they're correlated. The correlation coefficient is 0.5. So they're kind of weakly correlated, what you could tell people. Now, I will show you in a different video how to compute the correlation coefficient. Well, why not just go ahead and show it here? I'll tell you what I'll do. I have to put my screen up, and I'll take you to Microsoft Excel, show you how to do this in Microsoft Excel. It'll make you mad that it's kind of so easy, but we can compute all the correlation coefficients. I'm going to go to Microsoft Excel. Okay, so let me get rid of the answers first and just take a look here. So first of all, we were rounding. In my example, we were using 3 significant digits. That's not the case in these data, but you'll see that correlation coefficient is going to be slightly different, but not too different. In order to compute the standard deviation, by the way, it's very simple. It's confusing. Okay, so in order to compute the standard deviation for Twitter, right? I just type in =STDEV, and I'm going to compute for the whole population P for the prices of Twitter. Gives me 1.47. Well, that's exactly what we got. Okay, so I can also compute that for Caterpillar by dragging this over, and we find standard deviation for Caterpillar is 1.64, so I'll just rename this STDEV. Standard deviation for Twitter is 1.47, standard deviation for Caterpillar 1.64. How about the standard deviation for Apple? Easy enough, 2.7. Okay, so the correlation coefficient, this is the really correlation coefficient. Well, I've got to specify between what? Okay, so this is rho, or the correlation coefficient, between Twitter and Caterpillar. Okay, so here's how you compute that. You put the equal sign and type CORREL and open parentheses and get your first set of data in there, put a comma, and then get your next set of data in there. And then that gives us a correlation of 0.45. Again, based on the rounding is why our calculated is different than the calculation given by this program here. Well, what about the rho value, rho or correlation coefficient between Twitter and Apple? Right? We could sit here and recompute, but let's just skip that, and we can type correl, CORREL, and then capture the Twitter data again, comma. Now capture the Apple data and see if the correlation coefficient, we would expect it to be higher based on our hypothesis. Let's just see if it is. We might be surprised. Let's take a look. Ready, set, drum roll, 3, 2, 1. Oh, well. This is not a dollar value. So it's 0.21. So there's actually a weaker correlation between Twitter and Apple. Surprising. Interesting. Okay. How about, let's just finish it out. So we'll do rho between, I already did Twitter. So we'll do Caterpillar and Apple. All right. So that'll be Corel, Caterpillar, and then Apple. 0.7. So actually Caterpillar and Apple have the strongest correlation. So if somebody asks you, of these three stocks, which pair have the strongest correlation? Again, I don't know what this is calling it a dollar. You would say Apple and Caterpillar have the strongest correlation, because rho is 0.7, and that's the highest correlation coefficient for the portfolio. That's how you kind of answer questions like that. And I think that's interesting analysis. It's actually useful because if we were building a portfolio of stocks, there are a lot of formulas where we work with the correlation coefficient to build the portfolio based on the degree of correlation between two stocks. All right, so fair enough. Good job. This is pretty interesting, I think. So we'll go back to our screen now, kill the display, transition back. So I'll just finish up by saying good job. This document, if you want to access it, will be available. Download from the Google Drive link. You'll just have to trust me on the security of that. And here is our formula. Nice and neat. You calculated this today, so make sure to go tell your friends that you were able to calculate it. I actually never, in all of my schooling, ever tried to calculate this just by looking at it. I always made a cheater table. There's nothing wrong with that. So in future videos, we'll take this even greater. We'll go down the rabbit hole even further. But for now, we'll stop there. And thank you for watching. Please make sure to like and subscribe. And we will call it a day there. Thank you very much. Bye.